Dear students, we are discussing properties of inverse trigonometric function, and today we are going to discuss property number 5. We have to prove that tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy, where xy is greater than -1. The b part, tan inverse x minus tan inverse y is tan inverse x minus y upon 1 plus 1 plus xy, and twice tan inverse x is 2 tan inverse 2x upon 1 minus x square. Now we will here prove part number a. If we put in a, tan inverse equals to a, tan inverse y equals to b, which implies that when tan inverse x is a, implies that tan a equals to x by using the concept of inverse and composition of two functions, that is by composing tan on both sides. Similarly, tan inverse y equals to b implies that tan b equals to y. Now you know that tan of a plus b is tan a plus tan b upon 1 minus tan a tan b. Now tan a plus tan b, here tan a is x, tan b is y, and 1 minus xy. Now which implies that tan of a plus b is x plus y upon 1 minus xy, or a plus b is tan inverse x plus y upon 1 minus xy. Now here we will again use this a equals to tan inverse x, b equals to tan inverse y here, which implies that tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. So this is part a of this, where xy is greater than -1. Similarly, if we put in this tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy, if we put y equals to -y in this identity, you know that tan inverse of -y is -y, which implies that when we put tan and y equals to -y, you will get part b. Similarly, this tan inverse x plus tan inverse y is true for each and every y. In particular, it is true for x equals to y. So when we replace in part a x equals to y, it is tan inverse x plus tan inverse x is 2 tan inverse x, x plus x is 2x here, and 1 minus x into x is x square. So in this way you can prove these three parts. Now if we consider the expression root of a square minus x square. Now in order to simplify this expression, we will use here substitution. Now if we have expression containing this a square minus x square in the square root, there are two ways to solve this one. If we put x equals to a tan a cos theta, or x equals to a sin theta. Now when we put x equals to a cos theta, now this expression root of a square minus x square becomes a square minus, in place of x square, if we put x equals to a cos theta, it becomes a square cos square theta. Now in the square root we have two terms with a square common, so taking it out, it is a square into 1 minus cos square. Now 1 minus cos square is sin square, and a square sin square under root is simply a sin theta, which implies that this expression, this root a square minus x square, on putting x equals to a cos theta, it becomes a sin theta, a sin theta. Now similarly, if here if we put x equals to a sin theta, it becomes a cos theta. Now when we put here, we put x equals to a cos theta, this expression becomes a sin theta. Now here theta is new variable, so we have to replace this new variable by the original variable, which is x. So x and theta are connected by this x equals to a cos theta, means x cos theta equals to x by a, cos theta equals to x by a, or theta equals to cos inverse x by a, which implies that this root of a square minus x square is a sin of theta. Theta is here cos inverse x by a. Similarly, if we put x equals to a sin theta, it becomes a cos of sine inverse x by a. Now it depends upon the situation, which either we use, if we need cos, then we have to put x equals to cos. If we need sine, then we have to put x equals to a sine theta. Now question 1 of this exercise first is, we have to prove that the sine inverse 2x root 1 minus x square equals to twice sine inverse x. Now here we will consider this LHS of this, which is sine inverse 2x root 1 minus x square. Here we have root of 1 minus x square. Here we will firstly simplify this angle, that is 2x root 1 minus x square, because it is a rational term of this. Now here we will use x equals to a sine theta, because here a is 1, which implies that if we put x equals to sine theta, it becomes theta is sine inverse x. So this means that this LHS part, it is sine inverse 2x root 1 minus x square becomes sine inverse 2 sine theta root of 1 minus sine square theta. Now root of 1 minus square is simply cos theta. So here we have sine inverse 2 sine theta cos theta. Now you know that y sine theta cos theta is sine 2 theta. Now sine inverse of sine is simply this identity function, that is we will get simply 2 theta. Now theta is the sine inverse x. Here sine inverse x, because theta is sine inverse x. This is new variable. We have to replace this new variable by the main variable or the initial variable. It is simply twice sine inverse x. So substitution makes this in a simpler form, that is sine inverse. By using the substitution, we can say that sine inverse x, sine inverse of 2x root 1 minus x square is simply twice sine inverse x. You also know that sine 3 theta or sine 3a equals to twice sine 3a is 3 times sine a minus 4 sine cube a, and cos 3a is 4 cos a minus 3 cos a. Now we have to prove that 3 times sine inverse x is sine inverse 3x minus 4x cube. Now if we put in this here, if we put x equals to sine theta, so here in the angle, in this angle, that is sine inverse of this 3x minus 4x cube, if we put x equals to sine theta, now when we replace x by sine theta, it becomes angle becomes thrice sine theta minus 4 sine cube theta, which is simply sine 3 theta. Similarly in this, in cos, if we put x equals to cos theta, it becomes 4 cos cube theta. Angle becomes 4 cos cube theta minus thrice cos theta, which is simply cos 3 theta. Cos inverse and cos will cancel, so simply we get in part first we get 3 theta, and in second you get 3 theta. So here in first theta is sine inverse x, that is 3 sine inverse x, and in second sine this theta is cos inverse x, that is thrice cos inverse x. So in this way, by substitution we can prove that thrice sine inverse x is sine inverse 3x minus 4x cube, and thrice cos inverse x is cos inverse 4x cube minus 3x.